Hello everyone, welcome to Maths with Mr. J, and today we are going to learn about how to find the nth term of geometric sequence or geometric progression. Then the formula is given by Tn equal to ar raised to the power of n minus 1, where Tn is equal to the nth term, a is the first term, and n is the term number. Now let's take an example. We call this example 1. Now, first example reads, find the fifth term of GP 13927. Solution. Using the formula Tn equal to ar raised to the power of n minus 1, where a is equal to the first term, here we have 1. R is equal to the common ratio. Common ratio means the preceding term divided by the first term. 3 divided by 1 gives us 3. 9 divided by 3 gives us 3. 27 divided by 9 gives us 3. Common ratio is different from common difference. In geometric progression, we divide to get the common ratio, and when we multiply, it increases geometrically. So that is the difference between geometric progression and arithmetic progression. Then we continue. If we have this, n is equal to 5 because we are asked to find the fifth term. Then if we slot this value into the formula of finding the nth term, we have T5, which is equal to A is 1 times R, which is 3, raised to the power of 5 minus 1. If we continue, we have 1 times 3 raised to the power of 4, because 5 minus 1 gives us 4. Then we have 1 times 3 raised to the power of 4 means 3 times 3 and 4 times gives us 81. Then 1 times 81 gives us 81. So 81 is the fifth term. We can check by going back to the sequence. Since we multiply each term to give us the other term, then we say the last term here is 27. 27 times 3 gives us 81. And the position of 81 is the fifth term. Then our answer is correct. Now let's proceed to example 2. Now let's consider example 2. Find the seventh term of GP, which is geometric progression. We have sequence given as 3, 6, 12, 24. Solution. Using the formula of finding the nth term of GP, we have Tn equal to ar raised to the power of n minus 1, where a is equals to 3, which is the first term. R is the common ratio. The common ratio means the preceding term divided by the first term. 6 divided by 3 gives us 2. 12 divided by 6 gives us 2. 24 divided by 12 gives us 2. So 2 is the common ratio, and n is the term number, which is 7. Now, if we put this into the formula, we have T7 equal to A is 3 times 2 raised to the power of 7 minus 1. If we continue, we have 3 times 2 raised to the power of 7 minus 1 gives us 6. Then we still have 3 times 2 raised to the power of 6 means 2 times 2 in 6 places. That is 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. And 32 times 2 gives us 64. Then our final answer, T7, will give us 3 times 64, which gives us 3 times 4 gives us 12, carry 1. 3 times 6 gives us 18 plus 1 gives us 19, which is 192. We can easily check by listing the sequence, and we generate the sequence by multiplying each term by 2. That is, if we continue multiplying by 2 here, we are having 2 times 24 gives us 48. 48 times 2 gives us 96. And 96 times 2 gives us 192. If we check the seventh term, it will give us 192. Let's check. We have 1, 2, 3, 4, 5, 6, 7. The seventh term is 192. Now we proceed to example 3. Find the system of the GP 16, 8, 4, 2, and so on. Solution. We use the formula of finding the nth term of a sequence, which is Tn equal to a r raised to the power of n minus 1. If we look at this sequence, it's decreasing sequence. And the first term is a equals to 16. And r is the common ratio, meaning preceding term divided by the first term. 8 divided by 16 gives us 1 over 2. 4 divided by 8 gives us 1 over 2. 2 divided by 4 gives us 1 over 2. So when we multiply by 1 over 2 by each term, we get the next term, which is the common ratio, 1 over 2. And n is the term number, which is 6. Then if we put the value of 16, half, and 6 in place of a, r, and n, respectively, into this formula, we have T6 is equal to 16 times 1 over 2, which is the r, raised to the power of 6 minus 1. If we continue, we have 16 times 1 over 2 raised to the power of 5, which is 6 minus 1. Then we continue. We have T6 is equals to 16 times 1 raised to the power of 5 all over 2 raised to the power of 5. We can distribute the power. Then we have 16 times 1 raised to the power of 5 remain 1 all over 2 raised to the power of 5 is 32, meaning times 2 by itself 5 times gives you 32. Then if we continue, we can cancel out. 16 into 16 gives us 1. 16 into 32 gives us 2. So our answer is 1 over 2. Now we can quickly check if our answer is correct. We write check. We list the sequence, which is 16, which is the first term. And this sequence is generated by multiplying by half. 16 times half gives us 8. Half of 8 gives us 4. Half of 4 gives us 2. Half of 2 gives us 1. Half of 1 gives us 1 over 2. And if we count, half is the sixth position, which is 1, 2, 3, 4, 5, 6. So our answer is correct. Then we move further and take the last example, which is example 4. We'll find the 10th term of geometric progression, minus 3, 6, minus 12, 24. This look a bit tricky because we have both negative and positive sequence. We say solution. Using that same formula of finding the nth term of GP, we have Tn equal to a r raised to the power of n minus 1, where a is given as minus 3, which is the first term, then n is equal to 10 because that is the term number, which is 10, and r, which is the common ratio, is preceding term divided by the first term, which is 6 divided by minus 3, we have minus 2. Minus 12 divided by 6, we have minus 2. 24 divided by minus 12, we have minus 2. So our common ratio is minus 2. So we have negative first term and negative ratio. Now we put a, n, and r as minus 3, 10, and minus 2 into the formula. Then we have T10 is equal to a, which gives us minus 3, times minus 2, which is r, raised to the power of 10 minus 1. If we continue, we have T10 equal to minus 3 times minus 2 raised to the power of 9. Now at this point, this is equal to minus 3 times minus 2 raised to the power of 9 is having odd power. Odd power will give us negative value. meaning minus 2 times minus 2 in 9 places will give us minus 512. Then minus times minus in directed numbers will give us plus. So 3 times 512 is equal to 1536 as our final answer. If we want to check our answer is correct, what we do, we write check and list all the terms. If we list the first term is minus 3 times minus 2, which gives us 6, times minus 2, which gives us minus 12, times minus 2 gives us 24, times minus 2 gives us minus 48, times minus 2 gives us 96, times minus 2 gives us minus 192, minus 192 times minus 2 gives us plus 384. Then minus 2 times 384 will give us minus 768. Minus 768 times minus 2 will give us plus 1536. If you count these terms or sequence, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th one, which is the 10th term, is the answer. So our answer is correct. If this helped, please subscribe, like, and share. Thank you very much. See you in my next video. Thanks.